Hi guys, this is actually 2.5, but remember I told you it's the third chapter in our curriculum we have. So this is also the last section before your review and test. So you will notice that you have a review due this week as well. So let's jump right in. This is the bulk. This is solving. This is why we've been learning different things that we have. There are many real-world problems that deal with exponential. I mean, just think about how often you have heard exponential since the pandemic, because, you know, it's really easy to see that if one person gave it to another and then both of them gave it to someone else, like it gets really big really fast. That was the whole flattening the curve, is trying to make that not happen. So we won't be talking about those in our real world, but that's something that I just wanted to make relevant as far as like what's going on in today's world. Some other things that are really common are any type of earthquakes deal with log. So we want to know what order of magnitude is and the Richter scale. So the Richter scale is R equals log A over T plus B. All the things there tell you what they are. So A is the amplitude, T is the period of the seismic wave, and then B is the dampening of it. Also, any type of pH scale models also use log. So science is very popular. This would be chemistry. All right, Newton's law of cooling. So that's saying I have a hot coffee, and I know the hot coffee is, you know, so many degrees hot, and I know that the degrees in the house, you know, let's say is 72 degrees. I can use a model like this to state how long it would take for that coffee to cool down. And so obviously different factors come into play. What's the temperature that you're setting the coffee in? So like what's the room temperature, or if it's outside, what is, you know, the weather temperature? What is the temperature to the coffee to begin with? You know, things like that matter. But all of those things deal with exponential and logarithmic equations and can be used. Okay? So before we jump into the word problems, we will want to also talk about how to just do basic solving, right? Like I just need to solve for X, because if I know how to solve for X, it makes my word problem easier. So the two things we need to know for one-to-one properties. So if my bases are the same, then my exponents have to be equal to each other. Okay? So an example of that would be if b to the third equals b to the x, x has to equal 3 because they have to be the same. Okay, so that's all that's saying. So u equals v. The same is true for logarithms, that if you have the same log base something, the other part has to be equal as well. Okay, so same idea. If I had log base b of 3 equals log base b of x, no matter what b is, although I don't know why one's capital and one's lowercase, but anyway, 3 has to equal x, right? So make sure to fill this in on your next page. And that's kind of like for you to keep as your vocab page. And then meet me back at the next video so that we can practice solving equations.